this is the figure of pressure reducing pressure of this problem. So here I am going to explain constant net gearbox. Already last class we have discussed regarding gearboxes, what is a gearbox, what is the principle of gearbox, what are the different types of gearbox, and already we have discussed how the sliding net gearbox is work. In sliding net gearbox, a simple version of sliding net gearbox we have discussed. There will be 3 forward motor gears and 1 reverse. Similarly, transmission also we discussed 3 forward motor gears and 1 reverse. How transmission net gearbox works. So this is the diagram of constant net gearbox. So here also there will be a flex shaft. The flex shaft is attached with a gear with the lay shaft. There will be a driving shaft that is called a lay shaft and motor shaft. These two shafts, flex shaft and lay shaft, next to the gear. And in the lay shaft there will be some gear. There will be 3 gears or 4 gears. These 4 gears are constant next to the sum of gears on the output shaft. Okay. So these all the gears on the lay shaft are fixed to the some other gears on the output shaft. So the gears will not change. It will be constantly fixed. Okay. So the lay shaft gears are constantly fixed to the output shaft gears. But in output shaft, the gears, every gear with some bearing arrangement are flying on the output shaft. All the gears on the output shaft will be flying, and the gears there will be a flying shaft. And one more thing is, so here there will be between these gears there will be a dot flex. Dot flex means, okay, so if we engage with this dot flex, so if we engage the dot flex it takes the motion from the main shaft, that is flex shaft. If you engage the dot flex, it takes the motion. Like this, there will be 2 dot flexes. So by the moment of this dot flex, we can transfer the motion from the flex shaft to the output shaft. So here, first the flex shaft rotates. From the flex shaft, motion comes to the lay shaft. In the lay shaft, there will be 4 gears. All the gears are rotating. And so here, the output shaft is connected to the dot flex. Dot flex. So whatever the gear is connected by the dot flex, from the dot flex the motion will go to the output shaft. Okay. So here, left side there is one dot flex, right side one dot flex. Left side dot flex is connected with the second gear and third gear. Right side one is the first dot flex, right side one is second gear, and left side one is third gear. The third gear is the top gear. Similarly, the second dot flex, the left side one is the reverse gear, and the right side one is the first gear. So like this, therefore the 2 dot flexes, we can change the gear. Suppose, so if you take this as the second dot flex, if you move towards left, Then the first gear will be engaged, and the corresponding speed we can set to the output stack. Similarly, if you the second droplet, if you push towards right, then reverse gear will be engaged. Similarly, the first droplet, if you push towards right, then this second gear will be engaged, or if you push towards left, the third gear or high speed gear will be engaged. Like this, by the moment of this droplet, we are engaging the gear. But the gears cannot be moved. Gears are constantly making to the other gear. The total shaft or lay shaft gears are constantly making to the main shaft gear. So gears are fixed. Only with the help of the droplet, we are taking the gear ratio. We are taking gears. We are selecting gears. Like this in the constant mix gearbox. Only with the help of sliding motion of droplet, we can engage the gear. This is a very simple one. Very easy. There is no noise. There is no vibration, and wear and tear will be very light. You will see. The consequence gearbox is shown in the diagram. All gears on the main transmission shaft are constantly connected with the corresponding gears on the counter shaft or lay shaft. Okay. So all the gears are fixed to the counter shaft gears are fixed to the main shaft gears. In addition, two droplets are provided on the main shaft. So already we have discussed. One droplet is between the second gear and the flex gear. Flex gear means the top gear. And another is between the first gear and reverse gear. The splines are out on the main shaft so that the gears are still on it. Okay. The splines are there in the main shaft. Okay. And there is a moment of the gears are droplet over them. So in the constant gear box, top or third gear is assigned, it is the left droplet is slided to left. So when it is the first droplet, it moves to the left. There is a third gear, it moves to the right. There is a second gear. Similarly, the second droplet, if it moves left, it's the first gear, and it moves right, it will be reverse gear. And some advantages of constant mix gear. Generally, helical gears will be used for constant mix. Since we are using helical gears, the running will be very small. The gears are engaged by droplet. Okay, not by the movement of the gears. That's why gears cannot be damaged. Suitable design of the droplet gear changing can be made very easier. Especially the constant gearbox, the changing of the gears are very simple. Damaging of the droplet is very less because all the teeth are engaged at the side. So the damage will be very less in case of constant gearbox. So like this, in compared to the sliding gear, in case of sliding gearbox, gears are moving. Here, gears we are not moving, only with the help of the droplet only we are engaging gears. That is the advantage of the constant gearbox. It is very simple. There is no damage of the gears, and the gears, since we are using heavy gears, the running will be very small. So this is about the constant mix gearbox. It is very important gearbox. Most of the vehicles we are using constant